Hi, welcome to the channel. Today we will be deploying a project to Azure using one of the most popular infrastructure as code tool, Terraform. The core structure is that I'll be covering some basics and we'll be understanding Terraform in the first half of this course. And then in the later half, I'm gonna cover some advanced concepts within Terraform. So yeah, let's dive right in. And today's kind of the requirements, going over if you're following along as I build this project out. So first you need an Azure account and make sure you have a subscription within Azure that's, has valid billing, or has billing enabled, or if you're still using your student accounts or free tier, should be fine. Just make sure you have an Azure account. You will need Terraform installed on your dev machine or your local machine. And I'll go over the installation steps. It's pretty easy if you have used package managers before. And then you also need Azure CLI because that's how the authentication will happen between Terraform and Azure. And this is optional, but you can have a domain name. So since in the next part, we'll be deploying a website to Azure, having a domain name will make it more personal instead of having domain name or the URL that will be given to us by Azure. So it's an optional part, but if you want a domain name, you'll have to buy it probably. Or if you have already one, you can create a subdomain, but it's an optional requirement. Talking about Terraform and how basically it works. So infrastructure as code is an important concept within the DevOps principles. So it allows you to, define both cloud and on-prem resources in human readable configuration files instead of you going into the console and deploying infrastructure manually. You have the opportunity to automate it, have it version controlled, and you can also reuse these configuration files. And that concept of infrastructure as code, the tools that are in space are Terraform and Pulumi, and there are other tools that are available, just like Azure Bicep, right? The thing with Terraform is it's open source, so there's an open source version available, and you can deploy your infrastructure to any of the cloud providers. And I'll show you in the next diagram what I mean by that. Basically, how it works is there's a Terraform provider, which the engineers at Microsoft built specifically for Azure. And then similarly, there's a provider for GCP, Datadog, any of the cloud platforms that are available. That provider basically has a set of instructions for us to have in our configuration file, which then Terraform talks to the target API to launch the infrastructure. So that's basically how Terraform works. And this diagram is from HashiCorp. So this is not something that I generated, but in a nutshell, this is a brief explanation of how your configuration file works with a provider that is available on Terraform registry and then talks to the target API. Moving on to the next slide. So this is a bit more in-depth, explanation. So you have your Terraform project right here. You have your configuration file and a state file, and we'll talk about what is a state file. You write your Terraform code file, and the syntax that you use is called HCL. It's really close to JSON and a mixture of YAML, but you'll see it in action in a few minutes. And then, as I said, you have 1,000+ providers available from Terraform. And today we'll be using the Azure provider by Terraform, and you can pull that from the registry. So you write the code, you plan out your infrastructure, and then you do Terraform apply, which is the command, and that infrastructure gets deployed to the respective cloud provider. Now let's go ahead and going back to the requirements, let's make sure you have, the CLI and the Terraform installed on your local machine. So how you can install the Azure CLI is basically going through these instructions. So I have Azure CLI installed. If you don't, you can go to Microsoft Learn and just type in install Azure CLI, and this page will come up. Pick up your operating system. So it could be Windows or Mac OS or any of the Linux distribution that you might be using. And then basically go through the instructions on how to install or update the Azure CLI. So I have the latest Azure CLI installed, and I also have it authenticated to my Azure account. So the way you can do that is basically AZ login after you have installed it, and it will ask you to open a browser window and you will be authenticated to your Microsoft Azure account. I already did that, as you can see. So this is my Microsoft Azure account. And then the next step was to have Terraform installed. So it's really easy on Mac. You just do brew tab /tab, and then you do a brew install. So it uses Homebrew as the package manager. And then if you have Chocolatey, which is a free and open source package manager for Windows, you can do choco install Terraform. There's also a manual installation that you can do if you want to download the binary, and then you would also have to set the environment variable for a path. And for Linux, it's as easy as sudo apt-get, install. So since we are on Windows, I already have Terraform installed, but it's as easy as choco install Terraform. Make sure you have Chocolatey installed, otherwise you will have to go through the manual installation process. There is documentation available on, what is Terraform and how does it work. But since I've already given you a brief explanation on how it works, how it talks to the API, and what are providers, we'll be going ahead and trying it out in action. Talking about the Azure provider for Terraform, it's available on the Terraform registry, and you can go through the documentation on how different configurations look, how to deploy an Azure VM, how to deploy a cloud storage account, or how to deploy, something fancy with AKS. So all of those services, as you can see, are available on the right-hand side. As you can see, there is authenticating to Azure. So this is where our AZ, CLI or Azure CLI will come in handy. It'll use the locally installed Azure CLI to authenticate to the Azure account. So Terraform needs a way to talk to the cloud provider, in our case Azure, and today we'll be using the Azure CLI, but you can have other methods of authenticating Azure with Terraform. And we'll go back to my terminal. Forward, let's first create a directory, right? So I believe I already have one, but just to be sure, let's go into my GitHub folder. This is where I store all of my code. And let's create a directory called Terraform with Azure. Okay, awesome. So let's change to that directory. So Terraform with Azure. Let's open it in VS Code. That is my choice of code editor, and you could use any IDE. So I have my VS Code window open here, and as you can see, it's a empty directory. Let me just zoom in a little bit. There we go. So let's add an infra folder inside our directory. So I just created a folder called infra, and what I'm going to do is create a Terraform configuration file. And the way you do it is main.tf. So .tf is the extension of Terraform files. So there we go. You have main.tf, and usually how the infrastructure or how the Terraform best practices are, usually the file that has all the configuration for your resources and infrastructure is called main.tf. And that's why I named it main. And now the first bit that we need is the provider. So this is where you specify, hey, use, Azure provider. So let's go ahead and do that. So provider, and then we'll be using Azure RM. So that's how the Azure provider is named on the Terraform registry. And then features, we can leave it blank for now. So just because we are getting started. So this is how you define a provider block. So now Terraform knows that it needs to use Azure provider. So let's create our first resource. So create a resource group. So if you're familiar with Azure, you might know that you have resource groups, and within those resource groups, you have your resources like a bucket or a cloud storage account, an Azure VM, right? And I can show you what I mean by that. So going back to my Azure account, you need to have a resource group to allocate resources. So this is what we'll be creating. You can see I have many of these. So let's create a new one. So create a resource group, and now we will write some Terraform code. So resource, and then Azure RM resource group. There we go. And I have some extensions installed, which I think is the official Terraform extension, which helps, as you were seeing, it auto-populates what I'm trying to do, right? So Azure RM resource group, and then, so this is what the resource is called within the Terraform file. So this won't be the name in Azure. The name of the resource group in Azure will be this. So let's change that to Terraform demo. And for location, East US, because that's the closest location to me. And here too, let's, instead of RG, let's rename it to resource_group. And I'll show you what's the use case of having a name within the Terraform file, because we can repurpose this in the next code blocks that we will write. So this is not the name in Azure. This is the name that it will be referred to within the Terraform file here. So we have our resource group. To begin with, let's create a simple storage account, right? So let's go ahead and do create. So this is a comment. So comments in Terraform are by the number symbol and then whatever your comment is. So create a storage account. Okay, and then again, to create a resource, what you can do is type in resource, Azure RM, because that's our provider, and then storage account. So these instructions are already given to us by the provider. And let me find the correct tab. So if I go here and look for storage account, and on the left hand side we can see there's a resource called Azure RM storage account. So this is what I mean. So the instructions on how to use a particular provider are set by that said provider. So in our case, Azure RM has the instructions on how to create a storage account with HCL, which is the HashiCorp language. So that's what we have here. So let's rename this to something more unique. Terraform Toronto. And let's give it a number 6 at the end. Let's also add Azure here. There we go. And then, as I was mentioning to you, so the resource group name, instead of typing this, so we could have this here. So resource group name is rg-terraform-demo, which is this basically, which is what we named the resource group in Azure. You don't have to hard code it. You can use the property name within the Terraform code file. So what I did is Azure RM resource group dot resource group, which is this, dot name, which is this property. So that's how these resource names within Terraform come in handy. And same thing, as you can see, we did with the location is Azure RM resource group dot location, so it gets East US. So instead of hard coding East US here, we are picking it up from the previous block of code. And then account tier, we can go with standard, and account replication type is LRS. If I go here and do dot, you see how there's a comment or a highlight saying location, because that's Copilot that's recommending me to have this bit of code here. So Copilot, if you don't know, go check it out. It's an amazing tool. I just got access to it, I think a month ago, and you can install the extension on VS Code. There is a Terraform extension too, which is also helpful. So it reads the provider and generates generic code types that it thinks would be useful. So yes, Copilot and Terraform extension is what is kind of generating this before I even do anything. So you can see it already is trying to enable HTTPS traffic. The other thing I want to do with this storage account is I want to host. So the second part of this session will be hosting a website. So in order to host a website, I want to make sure, it's the storage account is set up in a way that it knows that we will be hosting a static website. And the way you do that is by a property called static website. And then you basically have to define an index document and an error 404 document. So let's go ahead with index document. And I want to name it index.html. So this basically is giving us a storage account which has static website kind of enabled. So Azure knows that this storage account will be used for a static website. So we have got, just doing a quick check, we have got our name, we have got our resource group, we have got a location, we have got account tier, which is basically you can go and read about storage account tiers within Azure. So we are using standard, and we have got a replication type, which is LRS. One thing I would like to mention is when you're using a storage account for static website hosting, you have to make sure the account kind. So you see how account kind came up? This is not Copilot, this is Terraform's extension. So the account kind is storage v2, and this is again something of a limitation from Azure. Not a limitation, but another property you need to add if you're hosting a storage, a static website on storage account. So I think we are good on the storage account resource. So we have our resource group, we have our storage account. Now we need a blob within the storage account. So let's go ahead and do that. So create a blob storage, or basically so that we can upload an index.html in the second session, right? Because we defined that our index document is this HTML file, which until this point doesn't exist. So that's what we are going to do. So let's rename this comment to add index.html file. Okay, so resource, and then again, you can go back here to the provider documentation and search for blob or storage blob. There we go. So this is how you can have a storage blob within the storage account. And going back to our code editor, let's type that out. Azure RM storage blob, I think it was called. Yes. And let's name it blob within the Terraform file. And now we can set the actual name that we were going to use. So name, Copilot is kind of right. We want to name it index.html because that's what we're trying to upload to our storage account. Storage account name And so remember, we don't have to hard code the storage account name. So you could either have this in double quotes, or you could do what we did here with the resource group name. So Azure RM underscore storage account, yes, and then it's called storage account within Terraform. So we'll have a period storage account and then name. So that will get the name of the storage account that we created previously. Awesome. So that's storage account name. We also need a container name. So storage container name. And this needs to be web because you use the web container for the static website hosting. So we were at the blob part of it. We just gave the container a web property. It's a good idea to never give anything a generic name. Always give everything a descriptive name. Yes, I highly recommend that. And you will see this Terraform file will evolve towards the second session because we are going to introduce variables. And we'll also tear apart this Terraform file into different sections. So instead of just having one main.tf, you'll see multiple TF files. And yeah, I just wanted to wait on that because so that this, makes sense as someone who might be a beginner. Moving along, we have storage container name, and we have that as web. We'll have a type, which will be block. Again, this is all that I'm reading or referred to here, and also the blob account or the blob documentation or the storage account documentation on Azure. It's nothing that I can bypass. I have to give those properties a type and a name. And then content type is gonna be HTML. So text HTML. And I think that's all apart from the actual index.html. So that's all we need for the blob itself. So for the source content, underscore content, you can either specify a file, but just to begin with the deployment side of things, let's just have our own HTML written right now. So we'll say, ahoy, this is a website deployed using Terraform. Look at that. Copilot even guessed what I'm trying to write using Terraform. Okay, so I feel like we have everything. So we have 3 resources in total. So the first one is the resource group, because we need a resource group for our resources in Azure. Second, we have a storage account that's set up to host a static website. And third, we have our index.html that we create. And that index.html basically has a text saying, "Ahoy, this is a website deployed using Terraform." So let's go ahead and save this. And now is when we'll be using the Terraform CLI. So first of all, I have to make sure I'm in the right directory. So cd infra, and then do Terraform init. So Terraform init is just like git init, how it initializes a Git repository. Terraform init initializes a Terraform project. So Terraform init. And as you can see, the initialization is downloading and installing the Azure RM provider from the Terraform registry. So now you can see Terraform has been successfully initialized. Now, if we do Terraform plan, you can see it has an error. So the error is name can only consist of lowercase letters and numbers and must be between 3 to 24 characters. So let's change that to something else. If I just get rid of these, and I think we should be good. So you can't have hyphens or dashes basically. And talking about the Terraform plan command, so Terraform plan will go through the entire Terraform file and we'll see what are the resources that needs to be deployed. It won't deploy it, we'll just show you the plan of the infrastructure. So let's do that again. Okay, I didn't save the file, my bad. So we'll do Terraform plan again after saving the file. And while that happens, I'm gonna get some water. Okay, so the plan gave us this output. And basically you can see all the things that are being created or we are planning to create. So the plus sign means, just like in Git, the plus sign means these are the things that will be added. So there is a resource group that's going to be added. There's a storage account with these properties that will be added. And then there's the storage blob that will be created for our index.html. And at the end, you get a summary of plan, 3 to add, 0 to change, 0 to destroy. So this is where the state file, remember we were talking about in the slides about the state file. So this is where the state file comes in. And you can see on the right-hand side of my files that there is now a folder that was created when we did Terraform init. And that folder basically contains the provider that was installed, which is Azure, and also has the state file. So state is basically how Terraform remembers what state the infrastructure is in. So right now it knows that none of these 3 resources have been deployed, and that's why the plan is to add 3. Once we deploy this and do any change, it will not add 3 resources. So you would see something like 1 to change, 0 to destroy, and 0 to add. And we'll see that. So that's a bit about the state. Now, there's another command called Terraform format. And what it does is basically formats your Terraform file or sees for errors in your Terraform configuration. So since I knew that the configuration looked fine, I didn't run that, but you can also run that to, make sure the formatting is good. Now let's do Terraform apply, and apply will deploy the resources to Azure. So let's wait for it to ask a message. So it'll ask you, are you sure you want to deploy this? And you have to enter yes, and you'll see shortly here. You can see in the terminal below, it has asked, do you want to perform these actions? Terraform will perform the actions described above. Only yes will be accepted to approve. So if you type anything else, it'll cancel it. So let's go ahead and type yes. And now it will start deploying these resources to Azure. And the way the authentication works, like how does Terraform know which Azure account that it's talking to, is through Azure CLI. And that's why I mentioned you need Azure CLI installed and authenticated so that Terraform can talk to it. There are different authentication methods that you can approach. We saw that in here. So we are using this method where we are using Azure CLI. You can have managed service identity, you can have a service principal and a client certificate, or you can have a service principal and a client secret, or you can also use the OpenID Connect. So these are different methods you can authenticate to Azure within Terraform, but we are using the first method today. So going back to our Terraform or our VS Code window, you can see the apply completed, 3 resources were added, 0 changed, and 0 destroyed. So let's go to our Azure account and do a refresh. And let's look for that Terraform demo resource group, which is right here. And you can see it deployed a storage account called Terraform Azure Toronto 6. Let me zoom in a little bit. And if you go within that storage account, you can see that if we go to static website on the left-hand side of the navigation, there is the primary endpoint, which is serving this document, which is index.html. So if we go to this URL, we should see our H1 HTML that we wrote, which is ahoy, this is a website deployed using Terraform, which is exactly what we had here. So we figured out how to create resources in Terraform. We saw how you can run Terraform plan to get a feel of what all resources are going to be added, changed, or destroyed. And then we did a Terraform apply, which actually deploys all those resources that you defined in your configuration. We also saw it in Azure live, that our website was deployed as a static website using Azure storage account. Now, the next part of this session will include some advanced concepts, as a few comments were mentioned, about naming conventions. I'll also introduce you to the variables and how to use variables within Terraform, and also a really cool concept of having a backend for our state file. If I somehow mess up the folder or the files that were created locally, which has the state file in it, I could be destroying my Terraform configurations. So it will not remember the state, and now I have resources that are deployed in Azure, which Terraform isn't aware of. So there could be a lot of confusion and issues, especially when you're working within teams and you have multiple engineers that might be working with the infrastructure using Terraform. That's when the backend, remote backend comes into play, where you can use a bucket. So in our case, we'll be using Azure storage again as the way to store our state file remotely. So it is not dependent on my local storage. So concepts like that will be covered in the second session. What I'm going to do is, since our website works and everything looked fine, I'm going to just do Terraform Destroy, which you might have guessed destroys your infrastructure that you just deployed. And you'll see a message saying, again, you have to type in yes if you want to go ahead and destroy it. So we'll wait for Terraform to come up with that pop-up while we wait. So now you can see, just like Git, you are seeing the red subtraction signs, which basically means it'll be destroying all these resources. And if you go at the end, you can see 0 to add, 0 to change, 3 to destroy. So I'm fine with that. So I'm going to say yes. And that will basically take care of cleaning up the resource group, the storage account, and the index.html file that we created today. But yeah, that was the kind of introductory session to Terraform and Azure and how the Azure RM provider works, introduction to HCL, and some of the concepts within Terraform. And as you can see, it's destroying the infrastructure right now. And we can also see that here after a few seconds. If I do a refresh, my resource group will not exist. We covered some of the basic stuff where, how to set up the Azure account, having the Azure CLI installed locally, installing Terraform, and also having a domain name, which is an optional because we deployed a website to Azure storage. So that was the project we deployed using Terraform. So there were 3 resources that we deployed: the resource group, the storage account, and blob container, which basically held our index.html file. And today we'll dive into a bit of a deeper concepts about Terraform, and I'll show you what I mean by that. So let's get started. So as you can see, I have my Azure portal open here, and we'll go to resource groups, and let me get you up to the speed with Terraform. So this is the code that we wrote in the previous session. So we have our provider, we have 3 resources, as I said. One of them is the resource group, we have a storage account, and we have our index.html, which served as the website. So the index.html was, ahoy, this is a website deployed using Terraform. And at the end of the last session, what we did is we destroyed our infrastructure. So I didn't want to, pay. First of all, it costs very less to host the static site on the Azure storage. But also, I wanted to show you the functionality that Terraform has with the command Terraform Destroy, which basically goes ahead and destroys all the resource that you might have deployed. So at this moment, if I do a Terraform plan, I have my terminal open here. And Terraform plan, if you remember from the last session, is the command that gives you the output of what all infrastructure changes might be deployed. So we need to do a Terraform init first in order to initialize the backend. So that is the first concept that I wanted to cover today, which is having a remote backend. So remember, we talked about having the state files, right? The state basically remembers what all parts of the infrastructure has been deployed or need to be deployed or need to be destroyed. So the changes within our state of infrastructure is stored in these state files, which were created by Terraform when we did Terraform init. And I also mentioned that if you're working in teams, right, if you have multiple engineers that are working with Terraform as an IAC tool, you might want to have this state file in some location that's, shared. So maybe like Azure storage, right? You can also use Terraform Cloud or any of the, storage services like GCP has buckets and AWS has buckets. But we'll be using Azure Storage to store our Terraform state file. And this concept is known as remote backend, right? So what I'm going to do is create a new file called backend.tf. And right now it's blank. So what we'll do is write some Terraform code. Before we do that, we need a storage and a container. So we need a storage account and a container within Azure. So I will be using Azure CLI to create that. So if I open, so this is my terminal here, and I have some commands that are, already copied. So I'm gonna go ahead and create a storage account called tf state reshape. The location is going to be ESTUS, which is the closest to me. And the resource group is tf state-rg. I'll link the GitHub repo that is available, so you'll have access to these commands. But I'm basically using Azure CLI to create this. You can also use the portal, so you can go through the web portal and create a storage account. But with CLI, it's pretty easy. It's just one command, right? So let's create that. Okay. So we got an error saying the resource group tf state-rg could not be found, which is correct. I just never created that resource group up until now. So let's go ahead and create that resource group. So AZ group create, and the name is tf-state-rg, and the location again is ESTUS. So this will create a resource group for us in Azure. And now we can run the storage account creation command. So that will take a few seconds, and it will give us a storage account to work with where we can store our state files. So let's wait for that to happen. Okay, there we go. So we have a storage account that was created for us. Now what we want to do is create a container within the storage account. So let's do that. I believe I have that command somewhere in my history because I was testing this. So we have the storage account create, and now we have the container create command. So the other thing you need is the account key. So you can run this command to output the account key and save it in your variable, which is $account_key. So the command to get it is az storage account keys list, and then it basically looks for the storage account tf state reshub and gets and save that account key value into this variable. So I'll run that before we create a container because it needs to, needs the key to create that container. So now we can run the container create command, and all of this again can be done via the portal, which I believe some of you might find easy because there is a UI aspect to it. With the commands, you have to memorize the commands. So az storage container create, account name is the same as we did create one. The name of the container that I will be naming is tf state. Public access is off because it'll have our Terraform state files. And then account key is this variable. So let's click enter. And there we go. So now, if I go back to my portal here, too many tabs. There we go. So in my portal, if I refresh, we should see tf state-rg as a resource group now. It has a storage account. And if we click on containers, we should see a tf state container, which is private. Awesome. So we did all of that just with Azure CLI. Okay, so now let's go back to our code editor. I'm going to bring this down a little bit, and now we can set up the backend.tf. So let's write some Terraform code. So Terraform and then backend, right? So what we'll be using as a backend, you might have guessed it, is Azure RM, just like our provider in our main.tf. So Azure RM is the backend that we'll be using. And then there are a few things that you have to specify, like resource group, account storage, like the storage account name, the container name, and what the key of the file will be where this terraform.tf state will be stored. The resource group name is, I forgot. So let's go back to the portal and see what the resource group name is. Oh, it's tf-state-rg. tf-state-rg. And then we have the storage account name, as you can see. So this is Copilot in action. It automatically generates, kind of code for me. So the storage account name is not tf state Toronto 6. I'm so bad at memorizing. What was it's tf state reshub. So this is the storage account name. tf state reshub. And the last thing is the container name. So the container name is tf state, which is correctly guessed by the Copilot. So let's see containers. Yes, it's called tf state, no dashes. And the last thing is key. And the key is the state file itself. So this is what the name of the file will be within the container. So you can see our state file was named terraform.tf state. We can save this. And now if I do terraform init, it will initialize the backend. So basically, now Terraform knows to save the state file in the container that we just created within Azure. So it's not only stored like locally, but it is in a remote location For us, it's Azure. And as I said, you can use Terraform Cloud. You can use any other cloud providers to store your state file. Awesome. So we have our backend configured. And now if I do Terraform plan, you should see an output saying these are the resources that need to be deployed. So in our case, it was resource group, a storage account, a container containing our index.html. So it's running Terraform plan right now. Let's see what it spits out. So you can see 3 to add, 0 to change, 0 to destroy. And you can also see all the resources. So this was the part of the first session, right, where we deployed the website using Terraform apply. The only change so far is the state file is now being stored in our Azure storage account that we created specifically for our backend. So that is the concept of remote backend. You can now work in teams, and the state file is securely stored in online location, so not just your local machine, right? Let's move on to other advanced concepts with Terraform. Let's go ahead and introduce some more concepts about Terraform. So a good practice of having your Terraform code is have it segregated into different files. So remember, we just had one file called main.tf. A good practice is to have it in different sections. So like provider, in our case, we only had one provider that we used called Azure RM. You might have multiple providers that you're using with your IC project. So you can have a provider.tf file, which just consists of all the providers. So let's do that. Let's create a file called provider.tf. And I'm just going to take this chunk of code, cut it, and paste it in provider.tf. So now we just have our resources in main.tf. There we go. So that is another, kind of good practice to have, is if you have providers, make sure it's in a separate file called provider.tf. The other thing is we didn't use variables at all. So we're going to be using variables so that we don't hard code things like name and location in our main.tf. And the way you do it is by having a file called variables.tf. Oops. So this needs to be inside infra variables.tf. Let's make this interactive. So put your thoughts in the comments saying what you think should be, what all variables you can think of within our main.tf. So I'll go with the first one, which is the location, because we'll be using, one location across the resource group, the storage account, and the blob itself. So I'm going to say location. So variable is called location, right? And you can have few properties about this variable. So, you can specify the type that it is a string, right? And you can also specify the description. So description being, it tells you what the variable is supposed to do. So the Azure region in which all this example should be created. Awesome. That is a great description, which was suggested by Copilot. So we are good on that. And you can also have a default value. So if a user doesn't assign this variable a value, you can have a default to East US. We'll not do that because I want the power of assigning the value. So we'll not go with any default values, but you can do that. Okay, so let's see what's in the chat. So I'm going to be looking at the chat right now. Resource group, the name of it. Sure, we could do that. So the resource group name. What would you think is a appropriate variable name? Resource group name? Sure, let's go with whatever Copilot is recommending. And the description is the name of the resource group in which to create the storage account. Awesome, that works. So we have two variables. So The other thing you can have is the storage account name. And think of it from a perspective that you have your IC code by multiple environments. So you might have a dev environment, you might have a prod environment, and you might have a QA or staging environment, right? So dev is for developers to test things out. QA and staging is whenever devs have shipped something, QA can do their testing, and then prod is your actual production environment. And you might have different storage account name for all these different environments, and also the category. So variable storage account name and description. Copilot comes in handy. It says the name of the storage account to create. Awesome. I'm happy with that. And then we can also have the source content. So remember, we weren't using an index.html file. We were hard coding the HTML. So we had an H1 saying this message. So we were hard coding it into our source content. So we were not using an index.html file, which in your case you might be, because that's where your code resides for your web page. So to make things simpler, we can have our source content as a variable too. So variable source content. And then the description is exactly the content of the index.html file. And similarly, you can have index document. We didn't have it in our blob, but let's say outside of this infra folder, you would usually have a folder called website, and that website directory would have index.html, your CSS files, all the static content that you're trying to deploy to Azure. And in that case, you would have a property here saying index document, and you can have a file that is in your website directory. And within variables.tf, you can have that as another variable. So that would look like this. So variable index, only if I can type, index document. And the description would be the index.html file of the static website. Okay. So we have our variables.tf already, and I think these are a good amount of variables based on our main.tf, right? So let's start using those within our main.tf. So instead of hard coding values now, we'll do var.resource underscore group underscore name, because that's what we use here. Awesome. And then we'll keep changing it for other variables that we just created. So var.location was the other one. Yes. What else did we create? Storage account name. So here's the storage account resource. Let's get rid of this and call it var.storage account name. And then we have index document and then source content. So since we don't, let's go here. So the source content is source content. Awesome. Source underscore content. So this auto completion is from the HashiCorp Terraform extension, because it knows other Terraform files. So var.source content, and then the name is gonna be the index document. So var.index document, because that's what we specified here. So the name of the index document is the variable, right? Awesome. So we can save that. And now, what is the next thing you think we will need to be able to deploy everything? It is assigning these variables values, right? Because here we just have the description and we didn't assign any default values. So we have to make sure we, have a resource group name, we have a location, we have our source content variable defined. And how you can do that is by adding a tf vars file. So you can do that in CLI too. So there are arguments that will allow you to assign variable values, or you can specify a tfvars file. So let's do that. And this is also how you can have different tfvar files for different environments. So think of, like, let's name our tfvar files dev.tfvars. So that will be the variable values for our developer environment. And then similarly, you might have prod.tfvars. Those will have values that reflect our production environment. So you can do that. So I'm gonna name this terraform.tfvars, or you could name it dev.tfvars. And here we will assign all of the variables that we are using in our main.tf those values. So the first one is location and East US for me, since it's the closest one. The second is the resource group name. So resource underscore group underscore name. And let's name it RG Terraform Azure. I hope I don't have, let's also give it a number at the end so that it's unique. If I already have that resource group name, the storage account name. So storage account name, let's name it Terraform at Azure. Terraform Azure reship 07. I think that is pretty unique because the storage account needs to be unique. Otherwise, it won't create it. What other variable did we have? Source content. Source content is equal to. So what should be the message this time for our index.html? Do we want to keep it same? Do we want to change it? Let me know if you want to change it, but let's go with ahoy. This website was deployed using Terraform. Awesome. And the one variable we forgot is in the index document. So index underscore document, and it's index.html. Awesome. So 1, 2, 3, 4, and 5 variables. And if you go to variables.tf, 1, 2, 3, 4, 5. So we had 5 variables. We have assigned those 5 variables some values, and those 5 variables are also being used in our main.tf. So now you can already see our infra folder got bigger in the sense that we have more files. We have backend.tf, we have main.tf, we have provider.tf, and we have variables.tf, and also terraform.tfvars, which holds the values to these variables. Because earlier in the last session 2 weeks ago, we only had just main.tf and we were still able to deploy our infrastructure. But today we learned about some advanced concepts, to have our code that is production ready. So after saving this, what I'm gonna do is open my terminal here, clear the screen so that it looks good, and do Terraform. You can also do Terraform format just to make sure all the code that you wrote is, valid. But if I do Terraform plan, let's see if I can find what all resources needs to be deployed, and let's wait for it. And I'll do a Terraform format just in case. 3 resources to add, 0 to change, 0 to destroy. Let's do Terraform format. So the format has a short abbreviation called FMT. You hit enter, and you can see you didn't use the out option to save this plan. So, this is for the previous one. Terraform format, backend.tf, main.tf, terraform.tfvars, variable.tf. There were no issues found. So what I'm gonna do is Terraform apply. And let's wait for Terraform to ask us about the yes. command. So how it asks, hey, are you sure you want to deploy all these resources? There we go. And it only takes yes as the approved answer. So I'm going to say yes. And now we wait for our storage account to be deployed. It did create the storage account, which is awesome. So let's go ahead and go to our portal, into our resource groups, and do a refresh. Should have RG Terraform Azure 07, Terraform Azure Reshup 07, and it should have a container called web, and there is our index.html that was created for us. And we can access this not through here, but through the URL that was given to our storage account. But here's the index.html that got created. Is there a way to see the content of this file? Guess not. Okay. So let's go back to our storage account here. And there should be a static website on the right-hand side, or sorry, on the left-hand side. And it should be enabled because we specified that in our main.tf. Now we access that, and you can see our website has been deployed. It says, ahoy, this website was deployed using Terraform, which is what we had in our variables or TF vars, right? This is the source content we want it to deploy. So you can already think of, let's say we want to have prod.tf vars. And for prod, maybe you don't use East US. Maybe it's some other region, right? The resource group name is something else. The storage account name would be, like, let's say you follow a good naming convention. So you would probably have something like prod dash Terraform dash Azure resource group. And similarly, you would have prod in your storage account name. Maybe you don't have the source content and you have the files available for your static website that you need to deploy. And so this won't be the value of the source content. It would be actually the files, the static files itself that you build for your website. And similarly, like someone suggested in the chat, you could have the account replication type as a variable. So something like var.account replication type, and you will have something better than just locally redundant storage, right? Maybe the account here is also not standard because it's a production website. So get the point. You can have, good variables defined, which allows you to have different environments and control those environments based on different TF-var files. Awesome. So that was the demo itself. We covered remote backend, and we can also see that. So if we go back to my Azure resource groups, we had a resource group that is just for saving my state file. There's the TF state, and you can see it has terraform.tf state file now, which was changed just 3 minutes ago because that's when we did a Terraform apply. So we'll see it live. Let's refresh it. Let's go back to our CLI here and do a Terraform Destroy. You saw the site was live. It created all 3 resources, and we were able to access our static website. Now what we are doing is destroying our resources. I am not sure what happened. An exception occurred in custom key handlers here. For more information. Okay. It's not responding anymore. So let's try opening another window. I hope it was not doing something already. Okay. cd infra Terraform Destroy. Now it'll ask us, hey, do you really want to destroy all these resources? And then again, we will have to enter yes. And after entering yes, when it's done its thing, we'll see that the terraform.tf state file, which is in storage account in Azure, will get updated. So this is where our state is being stored now. So it's talking to our storage account to get the state file and checking what things need to be changed. And now it has found that 3 resources need to be destroyed, 0 to add, 0 to change. You can say yes. And now, again, it will destroy those resources, talk to the TF state file that's in Azure, and update the state file. The destroy has been completed. 3 resources were destroyed. Let's go back and click refresh, and you can see it's 1:44 on the Eastern time zone, and it was the terraform.tf state file was modified just now. So that is the concept of remote backend, so that our state file is secure. We covered a bit about the variables and how you can have different TFVAR files to replicate different environment strategies like prod, dev, and QA staging. We also saw how you can assign those variables value by using a TFVARs file. We also saw how you can break down your main.tf into different chunks. So at the end, we had 5 Terraform files going from just one called main.tf. And what you'll see is once your infrastructure as code file gets really big, good suggestion or good practice is to have different resources within different files. So let's say this is the front end of our bigger project. So I would have something called frontend.tf, backend.tf. Let's say it involves 3-tier app where you need VNets, Azure VMs, and some database service. So you would have vnet.tf. You would have vm.tf, which is Azure VM, and you would have some db.tf. So you can, break down the Terraform files into different resources. And that makes it easy to work when you're working as a team, because sometimes these these ISC files can get huge depending on all the resources that you need for your project. So yeah, those are the good practices or best practices for Terraform, the advanced concepts that I just covered. I hope you enjoyed this session.